Well, welcome to week number 2, guys, as they say. So let's talk about what we did here. As you noticed, I did post the modules for week number 2. So hopefully you've already started, if not completed, the Patty's Industrial Hygiene text that we were talking about. So you should have those. The other thing, again, the Denari, Salvatore Denari will be going to second edition. Again, why I explained last week why we're using the second. It's not published. It's available through the library. We're going to look at SI units and basic. So you should have all this read before you take the week 2 quiz. So I'll go through this. All the PowerPoints I'm going to go through today are right there. So you have all those PowerPoints available to you. So then, of course, the problem set for week 2 will be due Wednesday at midnight again. And the chapter review, basically the homework, all, if you can see, Wednesday midnight. And this week, instead of an assignment, we're going to be doing a quiz. So the quiz will cover chapter 1 and 2. So you guys did get your books, the required text. Everybody got it? So what's going on? Yeah. You've got it? Okay, good. As long as you've got it, because that's going to make it very difficult if you don't have the required text. So I wanted to remind you guys about that, okay? So I'm going to start this out of week 1. So I'm going to skip one since you weren't here. And what'd you learn out of week 1?
For the week 1?
Yeah, what'd you learn? Just tell me one thing you learned.
It's about exposures, like all the different kinds of chemicals.
Okay.
Yeah.
Okay. Exposure, different type of chemicals. You guys, what'd you all learn? Ideal gas laws, thank you. My favorite one. You get the brownie points today. That's it. I love that one. What else? Now that she's stolen all the brownie points, there's lots out there.
About the industrial hygiene.
All right.
TLVs.
TLVs, awesome. So you learned a little bit that. You learned industrial hygiene. So we talked about international and all that. So out of the first chapter, you guys learned a lot there. Again, chapter 2. So what we did was the basic science. We did some basic equations. This week we're going to move into how do you go out. So hopefully we'll talk more about recognizing, but what you guys just started the process is, recognizing. Now we're going to talk about evaluating and how you evaluate, what the lab helps you do and things like that. So I always ask this, and I usually have a quick exercise. We'll probably come back and I'll do one here in a little bit, but I'm going to have you guys, again, why I have you bring electronic devices. So let's go through the first PowerPoint. And again, guys, this is not me talking, I hope. I hope you guys will talk to me. So, woohoo, we're week 2. All right. So again, when you signed in, you guys know when the final exam will occur. I'll probably give the same choice. We can do it online, have a certain cutoff, or you can come here and do it. So we'll take through that. So one of the things I'm going to go through is, so this is out of a book, Against the Gods. The idea of risk management emerges only when people believe that they are some degree of free agents. And it was Peter L. Bernstein, and they have something to lose. So I ask you guys, what is the most dangerous thing you've done today? And you have to jump in. What's the most dangerous thing you did today?
Maybe use the flat iron.
Use the flat iron. Absolutely. What's the dangers there?
Remember if I turned it off?
Oh, Yeah, that's awesome. So just to make you feel better, and this is being recorded, my wife, I always have to go behind her and check because she'll get about 10 miles down the road and she'll go, did I unplug the iron, the curling iron? So, yeah, call a roommate real quick. But anyway, no. So if that's that dangerous and you can get burned on it, why do you use that? You feel like even though you might have something to lose, there's a lot to gain. Yeah, I don't have to worry about it. I don't have any hair, guys, so I don't have to curl my hair. So, but great example. Thank you. Perfect. What else do we do that fits into this? Risk management emerges only when people you do that. No one forces you to use that curling iron, do they? If someone did, would you probably like it as well? Yeah, you probably think, are you kidding? So I always say that. So what else do we do every day? Come on, what's the most dangerous thing you got? Great example again. I haven't had that one, so. I know when I say the word danger, everybody thinks immediate serious injury, fatality, okay?
Driving.
Oh, thank you. Absolutely, that's the one I usually get. So probably you drove today over here. Why did you drive? How dangerous is that?
Yeah. Because I don't want to walk.
Yeah, absolutely. But it's so dangerous. Why do you do it?
Yeah, time.
Yeah, time.
To it.
Oh my gosh. You get in that car. How many of you, when you start up your car, start it up and think, I could die today? As soon as you start that key, you go, I could die today. I never think it. I get on it, push the button, starts up, and I go. I never think that. Why do we do that? Again, free agents. You guys got one more in the back for me? Any examples? Did you walk on the campus today? Is that dangerous? Yeah, crossing the road. I mean, how dangerous is it? Somebody sitting there on their cell phone driving. Is that dangerous? Yeah. So you guys walk to class. It's dangerous. Why did you walk to class? Again, the idea of risk management. So I want you guys to remember something. This won't be in a lot of the slides, but I was taught this, and the gentleman, I've used it, like I said, and you didn't get to hear my stories, in the Middle East, Southwest Asia, Southeast. I've also done it in South America. This is a great concept. Risk is equal to hazard, in other words, really what can hurt them, plus outrage. So you guys remember. So we just said driving in that curling iron and even walking on campus, pretty hazardous. But you guys don't worry about it. Again, you're a free agent, you'll do that. Now, if I took you to the top of the building and said, I'm going to push you off the building, but there's something at the bottom that will catch you, would you be happy with that risk? Why not?
Yeah.
Oh, you'd be happy? You'd be happy?
We have to
Well, you don't have to. That's exactly it. If I made you, but as a free agent, would you do it? No. Heck no. Yeah, but it's good. I'm glad you guys would do it. So I'm not going to make you jump off any bridges. So you're set there. You guys understand that? That's a key concept. Especially, I just had this week. I was talking to someone about risk, and they told me, oh, it was actually silica, which we talked a little bit about silica. The guy said, this is silly. I've been around silica my whole life. He's been 35 years. It's never hurt me. Is he correct?
No.
Well, he thinks he's correct. What is he? A free agent. So remember that. That's a tough concept. Okay. So here's your definition that I always use. You'll hear me say hazard plus outrage, but I want you guys to remember risk is really hazard, and again, times exposure. So a brief history, and we went through this sort of last week, but I want to hit it again. You guys realize the American Industrial Hygiene Association and the American Conference of Governmental Industrial Hygienists, and that was the first governing body, even in the world, that really came into being 1930s. 1946, 148 occupational health. As you go down through there, you can notice that all of a sudden we're starting to look at the total. Notice they did individual compounds. And that, again, these were maximum levels, maximum allowable chemical levels. That was the max. So as you're going down through there, your FDA used, what's LD50? Lethal dose. So here's a good question, and I'm going to do students because I don't want to be included. If I told you there's a lethal dose of 50%, and I'm going to give you guys all that dose, how many of you would die? 50%, LD50. How many of you are there? Mm-hmm. 4 people, I give you all so many kilograms of something. Let's say it's 25 kilograms is an LD50 of this compound, and I give it to all of you. How many of you are going to die? Okay, 50%. Come on. 2, thank you, that's it. Now, again, why will that not, that is, again, very protective. Probably maybe won't happen, but then again, maybe 3 of you will die. You never know, okay? So I always use this very quickly just to go, to use that on that. So again, some benchmarks, and I wanted you to see those dates. So the assessment process. So again, guys, recognize, industrial hygiene, recognize the chemical, recognize the hazard, then we're going to assess. So we're going to do hazard identification. Each example we talked about. What is the hazard with the hot curling iron? Heat. Right, absolutely, the heat. Driving. Sudden stop. Yeah, or hitting something. Walking. Huh? What's the walking? No, anybody can tell me. What do you think? What's the hazard with walking on this campus? Slip, falls. I didn't even hit that. Wow. Somebody could hit you. That's it. Okay. Exposure assessment. Now, I always ask this. Are we exposed to that curling iron right now? No. So it's not a driving, walking. So you've got to have that. When are they exposed? And you guys will hear that. Toxicity. In other words, how toxic, what's going on. And then risk characterization. When is it risky? I use this example all the time. Is it more risky to be in a high concentration in a small room of a chemical, or more risky to be in a big room with a little bit of a chemical? And I'm very much generalizing. Yeah, usually small, and I'm saying the same compound. I know people will tell me, well, it could depend on the compound because the toxicity. So again, that's what you go through on those and the answers. So quantitative health risk. You guys should have seen some of these definitions last week. We're going to go through a few of these. Again, no observable exposure limit. So your cancer risk and assessment and some of the slope factors. So we're going to stop and spend a little bit of time on this chart because this is a very basic of exposure. So again, if you look at what was done here, this was exposure to BMD and the percent animals responding here. So as you go along, percent animals exposed right here at 0, what percent are responding at 0? So you go up 0 and over, what is that? Again, 0 dose. Yeah, 0. So you guys see how the chart works? So I want you to go here. What happens at, let's say, I'll take it to 40 right here. What happens at 40? How much is response? Yeah, 0.1, 0.2, somewhere in there. Now, what we actually say, no observable adverse exposure level. What's that mean there? What's this point right here on this? And that's a little above 50. And NOEL, NOAEL. No observable adverse exposure limit. And you've got this in your notes, but I want you guys to see that. So what's it tell you below that dose there? From 0 to 50. And I want you to listen to my words carefully. No observable adverse exposure level. So I'm going to ask you guys, if I gave you a choice going back to the free will, I'm going to expose you to 0, or I'm going to expose you to, let's say, like 52, 53. Which would you choose? Because this is still saying there's no observable adverse exposure limit. It's kind of a trick question, isn't it? But what would you say? You guys know the answer. I give you two choices, 52 or 0. Which one are you going to take? Okay, you're braver. What would you do? There's no wrong answers, guys. You'd take what? 52? Go ahead. You're smiling. I hope you're going to say it. I wouldn't know. Here's my thought. I want you guys to realize, as industrial hygiene and occupational health people, okay, so we're saying adverse exposure limit or no observable, but we don't know what goes on. So my answer is always 0. I want you, but you're absolutely right. All you guys are right. Well, I could be exposed to that and not have an adverse exposure limit. You know, I always say you won't have something serious, but other. So here's a key point with what we're trying to do. As industrial hygienists, we try to keep it at 0 where we have no observable exposure limit. So just keep that in mind. So again, this is where they're defined. No observed adverse effect level, lowest observed adverse effect level, benchmark concentration, and uncertainty fact. So you can see your dose response. So what did I just tell you? The whole time I was talking to you guys, I said 52 ppm of something. So I'm exposing you to something and seeing what happens. Well, with humans and animals, we got to do milligrams per kilogram, or we got to take your body weight, because guess what? I've got a lot more body mass than you guys. If they expose me to something, I can take more because my body has more area to absorb. It's just pure size thing. So you need to keep that in mind. But there is your key dose response. So where would you guys use this? What are you going to think about? Where would you use this today? Tell me a chemical exposure you know of or something you're looking at. This is the part you guys talk to me, because I can't talk the whole time.
Any chemical?
I don't care. Yes, you can even do something not a chemical. You just tell me something that kind of hits this observable exposure limit. What is it?
Methane.
What's it?
Methane.
What was it?
Methane.
Methane. Tell me butane?
Methane. CH4.
Oh, methane. Okay, good. Yeah, I can't. By the way, I'm from West Virginia, so I don't talk well. So go ahead. Tell me about methane. What happens? Yeah. This is why I want you guys to think. And if you can't come up with a good example, I'm going to give you a really bad one. I'm going to walk you through one. Then I'm going to make you guys all think about one. So there's something called ethanol. Do you guys know what ethanol is? So ethanol is used recreationally, correct? Did you all know that people use ethanol as a recreation, kind of relax? What do they call that? In the U.S. anyway. Alcohol. Ethanol is alcohol, okay? So what effect does it have on people? Go back to this chart and let's kind of use it. So right now, and I'm assuming this, so don't tell me, you may have to have a couple of drinks before you come to class to put up with me, but right now, I'm at 0, you guys are probably at 0. well, let's say this was, stumbling, or let's say this was happiness, or whatever we wanted to measure. So at 0, you'd have 0, which is class, okay? As I gave you 50 ounces of alcohol, what would happen? You might still have no observable, but then when I go to 100, what's going to happen there? Yeah, you may black out, you may, depending on what the dose is, you may stumble. That's the example that a lot of people use, and that's kind of a real-world example. The one with methane, usually people hit carbon monoxide.
Yeah.
So what happens with carbon monoxide? Absolutely. And when it combines with the hemoglobin, what happens for oxygen transfer? It ends, doesn't it? Perfect. So what happens if you don't transfer oxygen to your body? Yeah, it's real easy. You don't live very long. So I want you guys, there's a couple of examples. You guys, I want one more out of you all. You can do it as a group. Come on, one more. Give me a not observable adverse limit. It starts at 0, you don't have, and then all of a sudden you have an observable limit. Go ahead, scream it out. You guys, this is a wide open class. I want you guys to talk. This is how we're going to learn. What's that? Sorry? Nitrogen. Beautiful. So what's nitrogen do?
In case of oxygen, if you take more nitrogen, carbon monoxide.
Correct. It's it's an asphyxiant also. Great example. Thank you guys, because this makes it easier when you all help me out. And that way you get examples. So here's one, and you can see the bromopropane that we were just talking about here. This was actually part of the study. So ACGIH, their TLV, which again are the TLVs in the U.S., do we enforce those? Can you get a fine with a TLV? Does OSHA or our regulatory body worry about TLVs? And the answer is no. I'm not even going to keep pressing you guys. No, they don't. So they say the LOAEL is 100 ppm. And if you go down through here, some of the critical toxicity in their study was Huntington disease, and that was 2001 they found that. So again, here as you go down through there, each of the limits are set and what happened there. And again, that's part of the research. So some examples, and acetylcholine, where is that used? What do you guys think? Nerves? You've heard that? Yeah. On that. In other words, acetylcholine esterase, an enzyme that breaks down acetylcholine. So again, as you're going through, you can see what happens there. So that's some of the chemicals that'll go through and what ends up as they break apart. So what do you guys think an adverse effect is? No? I mean, go ahead. So you think, what's that one say an adverse is? I think you kind of hit that. CNS, absolutely. Central nervous system, yeah. So what's this one talking about? What's that a photo of? Kind of a bad photo. Yeah, it's kind of a skin. You can see the brain here. You've got different cells. So again, what were our routes of exposure last week? Inhalation, ingestion, we can go through them all. Skin exposure, yeah, all those are on there. So again, selecting your uncertainty factor will also go through and actually set. That's why when I said if I gave you all an LD50 dose, maybe not 50% of you would die, maybe only 25% would, or maybe none. It depends, because again, that is animal studies and looking at those. So some typical EPA uncertainties as you go through there, and this is why we always have those uncertainty factors. So you do the experiment with animals, and you say, I'm not really sure of the data, I'm going to apply this uncertainty. And I want you guys to understand that. So, again, concentration, response. You can see here is the human, and here's the rat. So I always say this, if this chemical was exposed all the way up until about right here, you have basically no exposure. But the problem with the rat is down here, you're starting with the human to get exposure. That's why sometimes they'll have that uncertainty there. So, some of the risks there that we'll go through, 1970 to 80, I'm not going to spend a lot of time on Delaney Clause. Basically, this was where it was an old workers' comp thing that in the U.S., you guys, I'm not going to spend a lot of time, but the lowest feasible level, not balancing risk and cost. So what do you think's really changed with this definition? Now we're saying in the 80s, significant risk was 1 in 1,000. Now it's 1 in 1 million. So what do we keep doing with this wonderful risk? Yeah, we're minimizing it. Hopefully we're getting better, guys. That's what you should see. Each of these, if you look, here we were worried about risk and cost. In other words, so we stopped doing that and we said, well, significant risk, and then we redefined that. So, once again, some of the concerns, we'll go through that, is trying to get the social context, trying to get toxicity separated from physiology. I always ask this, has anybody taken any toxicology? Have you guys done any of that? Okay, it's a great course. If you get a chance, take it. Dr. Litchfield does a great job with it. You guys would enjoy it. So, again, here's your IH model we talked about, anticipate, recognize, evaluate, control. You guys will hear that over and over and over and over again. So we're going to spend a lot of time about evaluating this week, and we'll go back and do more with the recognize and anticipate. Here's your EPA model, hazard identification, toxicity, exposure, risk management, risk communication. Why am I wanting you to know these two models? What do you guys think? I'm going to ask this. What are industrial hygienists concerned about? What do we worry about? What was it? Controlling the risk for what population? For what population do we worry about? For workers. What about the Environmental Protection Agency? Who do they worry about? The community. Big difference. People really get hung up on, why do they have different risk assessments? And a lot of people don't understand it's two different models. I always say when I'm talking to people about IH exposure, you will hear people, and I hear very talented professionals that will take industrial hygiene exposure and try to compare it to the community. And guys, that's not what it's intended for. The data will not support that. Now, does it work sometimes? Yeah, maybe, but there's still that risk that study and that risk was designed for 8 hours, 40 hours a week, 2,080 hours a year, whatever you want to say, and now you're taking it to 24 hours a day, 7 days a week, 300. Do you think those two can compare? And they can't, okay? So I just wanted you to see that there. So, kind of the examples that I've given you here, the OELs, the ACGIH has TLVs. Why are those useful for people practicing, especially outside of the U.S.? What does that give you? Okay, here's a better question. What's the difference between the OSHAPL and the ACGIH TLVs? What's that word? So if I expose you to a chemical, and let's hope I never did, above the TLV, what does the regulatory agency say? Will they fine me? Yeah, go ahead. Say, you think so, wouldn't it? Well, why wouldn't they? If you're above the threshold, let's say the threshold limit value is 25 and the permissible exposure limit's 50. And let's say I expose them to 30 ppm, and we're talking 25 ppm and 50 ppm. So I give you 30 ppm. Should I get fined? No, I won't. Why won't I? That right there. It's what's in the regulatory. Now, you guys, as good industrial hygienists, going back to your saying, no, you don't want to do that. If I've got a limit, I need to make people aware of it. And again, what's our goal for exposure? Zero. That's always it. We don't want exposure. Guys, two other examples that are not regulatory, but especially as you're practicing outside of the U.S. I've mentioned to you whether you go to Belize, whether you go to Kurdistan, whether you go to, I'm trying to think, France, Germany, England, wherever you're working, and let's face it, you may end up there. This is the most valuable information. NIOSH recommended exposure limits and the real guidelines. And as you're looking for chemicals, sometimes you won't get those there, but you'll go through some of these others. The other ones I want to talk to you about, and this is a favorite of mine because I, at one point, worked with a German company by the name of Bayer, or Bayer in the U.S. They call them B-A-Y-E-R. They have some great limits for chemicals, and they have some great research. Some of the German, if you do the whole Google search, you'll see they have a great limit, and they'll actually compare all the international standards. So just a good place to go look because, again, we're professionals. For a lot of people, when we're training them, they're going to practice in the U.S. only. Do you guys ever see yourself, and I say this to all my students, will you only practice in the U.S.? No, you guys won't. By the way, even the U.S. students will have to do it. When I graduated college, if I had told someone that I'd be practicing in different countries, they would have laughed at me. So that's why you guys have got to realize the world's very small. Canada, even with some of their standards, are different. So again, here's the other thing. I worked for a company one time that had a company-specific occupational exposure limit. So they were not happy. They said, you didn't get it right as a regulator. I think ACGIH, you're allowing people, we're going to set it even lower. So companies will do that too. So this is your list of where you want to go, and I can give you the pipe dream. Where would you want, which is say these all have values, which one would you want to use for your for what you practice at or what you'd recommend? The lowest, yeah, the lowest. A lot of people will say OSHA because that's what will get you fined, and that gets your boss excited. But you need to start thinking, and I want to encourage you guys, the right answer is, okay, I'm not going to get my company into trouble. I'm going to keep regulatory compliance. You guys need to realize that someone's, and I know this sounds funny, mother, daughter, husband, brother that you're taking care of, so you want to set the lowest limit that protects them, okay? I know it's not always feasible, but that's what you want to do. So as far as the occupational exposure limits, again, ACGIH published them in 46, and they have changed. So I usually at this point encourage you, if you're online, I always look at what were the TLVs developed for. And I want you to quickly look at, they are published in peer-reviewed literature. They're health-based values. Represent conditions. So again, nearly You hear these words? Nearly all workers may be repeatedly exposed without adverse health effects. TLVs and BEIs, biological exposure indices. What are they not there? And I want you guys to scream them out. The first one. What are they not? Yeah. So guys, I hear this all the time. I'm exposed to 25 ppm of chemical, methyl ethyl, whatever. The TLV says I can be exposed to 35, so I am safe. Yeah, I want you guys to get out of that and start thinking, that's not what the TLVs were intended for. Again, nearly all the workers. So what's this one mean? I just gave you an example. If I am exposed to, the TLV says 35, and I'm exposed to 30, is it toxic? Not toxic. Maybe that's exactly it. It basically is a relative index of toxicology, because I'm going to give you an example. Let's say I suffer from asthma or chronic obstructive pulmonary disease, COPD, and I'm exposed to that chemical and it causes breathing problems, and at 30, the normal person, I'm okay. They're going to be okay, aren't they? At 25, what may I do? I may have problems because of my other diseases. So I want you to understand a relative risk of index of toxicology. And then quantitative estimates of risks of exposure by different paths. So I always say this, sometimes we talk dermal versus inhalation versus, other type exposures, you can go through it. So, what are the TLVs good for? What would you use them for? Right there. Represent conditions under which nearly all workers can be repeatedly exposed. So, with that said, they're not legal standards. And go through that. There are guidelines to assist, and there are recommendations for the practice of IH. So as we're thinking through that, that's what you want to keep in mind on those. So here's some examples of TLVs. So you can see sensory irritation. So what's it mean? What's going to happen? And you guys may know this, ammonia. What's it going to make you do? Yeah, itchy skin going through that. We already talked a little bit about this compound called ozone. Yeah, ozone. Why? And that's a community, but we also have it. I always tell people we had a copying machine, copying room, a lot of copiers in it, and they had a high ozone level. Kind of interesting. Okay, again, some of the solids as you're going through, the calcium carbonate, physical irritants, and then normal hexane or your 6 compound. Again, some of the effects there. And I tried to give you a few more. Again, the benzene cancer is one that you'll see a lot and people will use for examples. Okay, so I'm going to go through each of these fairly quickly, but I wanted you guys to at least see each of them there. TWA, time-weighted average, short-term exposure limit, BEI, and carcinogen. So the STEL. If you look at that, the thing you need to remember, a couple of things here. 15-minute exposure, and should not exceed any time during the 8-hour workday, even if it's within the TLV or the TWA, provided the daily TWA TLV is not exceeded. So what this says is, for a short period, maybe you can be exposed to this and not have an adverse effect. BEI, biological exposure indices. Basically, you'll hear me use an old school term called body burden. How much can my body take? It's a horrible example, but it works really well. Again, we talked about ethanol, or people will talk about alcohol. Different body burdens. How much alcohol can someone take in? Depends on their size. So I want you to remember that. Indicator of the uptake of substance. How much gets in? They also represent levels of determinants, and again, the inhalation exposure or even skin exposure. So carcinogen. And this, when you look at the standards in the book, and I always ask you guys, if you ever want to see some of these, or you say, hey, you can't really get it online, I warn you, this is the book I told you they charge you about $65. Usually every couple of years, get 1, 2 to 3 years. They change, so you have to do it. But again, these are the indicators, the A1, A2, as you're going through it, A3, A4, A5. So obviously each of those will be classed. And if you remember last week on the chart I was showing you, that's where you'll see those. So again, the Pell. Why is this important in the U.S.? Why do we worry about the Pells in the U.S.?
There's a lot of industries now.
Yeah. What do most businesses, why do they operate? Yeah, to make money. That's it. So what's this one do if they exceed one of these Pells and OSHA catches them? They're going to fine them, they're going to take money away, and more than that, it's very embarrassing. So this is available online. I always tell you guys it's a good reference. Your 29 CFR 1910-1000 gives all your TLVs, carcinogens, and some of the dust exposures. So we did a couple of problems like this. As you're looking at this, what do we do with the time-weighted average? And if you look at it, this was an exposure, and this is always what I say. Usually, time-weighted averages are 8 hours, and we'll talk a little bit more about it. I brought some of the standard sheets, but you can't adjust this around because some people work 8 hours, 12 hours through there. So, average exposure for an individual, this is how we calculate it. I'm going to go ahead and give you guys, and this is very simple. It's a sheet that I'll refer to occasionally. It's just some useful equations for actually that people use this on the American Board of Industrial Hygiene calculations. Available online. So all you got to do is type in ABIH calculation sheet and it'll be there. So on the, let me look very quickly. I think it will be, if you go on the, yes, back, oops, sorry about that. On the back of page, let me see where it is. Trying to find it here. Yeah, let's go to the back of page 1. Do you see that formula somewhere there? Welcome, Michael. Or do you see a formula very similar? So I want you to look in there. You're going to see on the third row, all the way to the right, do you see a formula there that's very similar to that? And what's it have? TLV with an underscore mixture, doesn't it? So a little bit different spin on it on the TLV formula, but what's this one mean as you look at this? What's this C stand for? Concentration. Yep. What's the T?
Temperature.
Time. Yeah, it changes around from my ideal gas law. And what are these? All the times added up. So, use this for an example. So, at hour 2, what was the exposure?
300
So for 2 hours, and this is skewed, let's say instead of going like this, let's say it came straight across, he was exposed 300 2 hours. So what would be your C1, T1? 2 hours times 300. So again, that's how it's used. And what's your time-weighted average? It gives you an exposure over the 8 hours. Very simple mathematics there. So let's kind of talk about this. It's the average exposure for an individual over 8 hours working, taking one or more samples. So again, C1, T1, C2, C2, and that CN just means you add those up. So let's look at this one. You guys tell me. This is where you pull out your calculator. I want you to calculate what was their time-weighted exposure for this particular sample. What was the answer? 88.75. So I'm going to give everybody, somebody got an answer I thought I heard, so. So again, unit ninjas, what's the answer there? I heard 88.75. We never have a number without a descriptor, so what is it? ppm, okay? So that was one. Do we have anybody that agrees, or are we all just going to follow blindly on that? Everybody agree with that? I hear one. Michael, you say yes? You agree with them? Okay, you saw it. That's it. Everybody else see? So let's talk about how did you get that answer? So tell me the first thing you looked at here.
Look at the concentration and the time.
Okay, so what was C1? 80, what was that? 80 ppm? What did we multiply it by? 2 what? Hours. Guys, I'm going to teach you. You're a unit ninja. Then what we do? We added. Okay? What we add? 110 ppm. Thank you.
Times 4 hours.
4 hours. And what was the last one we did?
55 ppm.
And 55 ppm times 2 hours. So are we done? We just multiply those and add them up, right? No. Thank you. So what are you going to do now?
The average time.
So it says there, how many hours were these samples covering? 8 hours. So, somebody do the math. What's 80 times 2? 160. What's 4 times 110? And what's 55 times 2? So when I add those up, what do they equal? Well, somebody said it. 7 what? 710 ppm, right? No, ppm what? There you go. And what are we dividing by? And when we do that complex math, 710 divided by 8, what do you get? Ding, 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 ding. So you guys see it? Now, again, as we're going through these, I'll spend some time in class on key calculations. Now, if you open up your textbook, what page is that calculation on? Anybody, do you have your textbook? You guys, again, you need to look at it if you have that. So it will be in your calculations under time-weighted average. I think it's page, I'll look it up and tell you later, but I think it's around 50, I thought it was around 50-something. I'll have to find that. Here it is. I am sorry, it is around page 35, 36. So that's where your TWAs and your TLVs with mixtures are there. Okay? Again, that's the advantage of the book. If there's questions, we can go through there. And as you see, you guys solved it, 88.75. Now, I always get this question about significant figures. If you're on a test or a quiz with me, I won't put an answer 88.75 and 88.55. It'll be really obvious what it is. Now, what I may do is, just so you guys know, I may do one answer where I don't divide it by 8. And if you just do the top and go through, you'll think, all right, I got the right answer. No, think about it as you're looking at that. So again, for an 8-hour day, this was kind of another calculation we did. Air sampling, this is in your notes. I'm not going to go through it. A little bit more complex, but also the same principle. What did they do there? 2 hours, same thing. So you guys can see that. So here's my question. What would happen if the person had a 30-minute lunch break instead of being exposed to 3.4 ppm? So what would happen if that was 0? What would it change? Let's say we get all the same readings, but instead of 3.4, that's 0. Would it change?
They're going to change the
What would it do to? What do you think? If this 0.5 times 3.4, this number here was gone, what would it do to this number? Going to lower it, or what happens to this number? So go ahead and do it on your calculator. I want you to add 3.2, 3.75, 1.7, leave that out, plus 2. And then divide it by 8. So what did it do? And you guys were right. So see, that's the effect that you can have on those two. So again, what's going on there? So exposure to a vapor with additive effects. Again, if you have a compound that's added together, it will create issues on that. And I tried to give you an example of an OEL for a mixture. I used a variety of parts dip, and you can see muriatic, nitric, and as we did the mixture, each of their OELs, or occupational exposure limits, were different. That's how you calculate that to get the mixture. So just so you know, where is that located in your notes? It is on page 35 in your required textbook. So if you look at that one and you go, I don't understand it, again, theory and application with an examples right there. So that's why that book is valuable. So what I'm going to do now, guys, is go ahead. We've been at it about an hour now. Let's go ahead and take a short break. So be back in here about 10 after, okay? Or take it back 5 after.